3I/Atlas, a cosmic mystery, flowing script. Intro. Hey there, welcome. Get comfortable, maybe dim your lights, and let's take a gentle journey through space together. Tonight, we're going to talk about something truly extraordinary. A visitor from beyond our solar system. A mysterious traveler that has astronomers around the world scratching their heads and asking questions they never expected to ask. This is the story of 3I/Atlas. And trust me, it's a story worth hearing. Just relax and listen. It all began on a summer day in 2025. July 1st, to be exact. While most of us were going about our daily lives, a network of telescopes called Atlas was doing what it does every night, watching the sky. ATLAS stands for Asteroid Terrestrial Impact Last Alert System, and these telescopes have one job: to spot things in space that might be headed our way. They're our silent guardians, scanning the darkness while we sleep. On that particular night, Atlas spotted something. At first, it seemed unremarkable, just another dot of light moving against the background of stars. The astronomers catalogued it as A11PL3Z and moved on. But within days, something didn't sit right. This object was moving strangely, too fast, and on a path that didn't make sense for something born in our solar system. Scientists took a closer look, ran the calculations again, and realized this wasn't one of ours. This visitor from beyond was given a new name: 3I/Atlas. The 3I means it's the third confirmed interstellar object we've ever detected passing through our solar system. Think about that for a moment. The third visitor from the stars that we know of. Before it came 1I/Oumuamua in 2017, that cigar-shaped enigma that sparked worldwide debate. Then 2I/Borisov in 2019, a more conventional comet that felt almost comforting in its normalcy. And now, 3I/Atlas. Three travelers from the cosmic ocean, each one carrying mysteries from distant shores. What makes something interstellar isn't just that it comes from far away. It's the path it follows. 3I/Atlas moves on what astronomers call a hyperbolic trajectory. Imagine a curved path that comes from infinity and returns to infinity. It's not bound by the sun's gravity like the planets and asteroids and comets that were born here. No, 3I/Atlas is just passing through, a cosmic tourist that will visit once and never return. It came from somewhere in the direction of the constellation Lyra, that beautiful harp in the summer sky. Out there, perhaps trillions of miles away, is a star system we may never identify. That's where this journey began, perhaps billions of years ago. And what a journey it is. 3I/Atlas is moving fast, remarkably fast. Nearly twice the velocity of our previous interstellar visitors. It's rushing through our solar system like it has somewhere important to be, covering vast distances at speeds that dwarf anything humanity has ever built. Yet despite this incredible speed, we're perfectly safe. The comet won't come closer than 1.8 astronomical units from Earth. That's about 270 million kilometers away. Far enough that we can observe without worry, close enough that our best telescopes can see it clearly. As 3I/Atlas sailed inward toward the sun, it reached what scientists call perihelion, the closest point in its path to our star. This happened in mid-November 2025, when it came within about 240 million kilometers of the sun. Not particularly close by cosmic standards, but close enough for the sun's warmth to work its magic. And that's when things started getting really interesting. You see, 3I/Atlas isn't just a cold, dark rock drifting through space. It's an active comet. It has a solid nucleus, a core of ice and rock, and as the sun's heat touches it, something beautiful happens. The ice doesn't melt. Instead, it sublimates, turning directly from solid to gas. This gas carries dust particles with it, creating a glowing cloud called a coma that surrounds the nucleus like a cosmic cocoon. Through our telescopes, we can see this ethereal glow, this halo of material streaming off the comet as it warms. The Hubble Space Telescope captured stunning images of 3I/Atlas, revealing the coma in incredible detail. The James Webb Space Telescope joined in too, using its powerful infrared eyes to peer into wavelengths invisible to us. Multiple observatories around the world and in space turned their attention to this visitor. Everyone wanted to see it, to study it, to understand it. The Swift Observatory, the very large telescope in Chile, even interplanetary spacecraft currently traveling through our solar system, all of them turned to look at 3I/Atlas. It became one of the most observed objects in the sky. And what they saw? Well, that's where our story takes a turn into the truly strange. Scientists estimate the nucleus of 3I/Atlas is probably less than a kilometer in diameter. Not particularly large, about the size of a small mountain. But here's the thing that made astronomers do a double take. The mass of this comet appears to be enormous. Around 33 billion tons. Let that sink in for a moment. This small object is incredibly heavy, anomalously massive, as the scientists carefully phrase it. It's estimated to be thousands to hundreds of thousands of times more massive than Oumuamua, and about 1,000 times heavier than Borisov. Now, you might be thinking, so what? It's heavy. But here's why this matters. In nature, we should see many more small objects than large ones. It's simple statistics. There are more pebbles than boulders, more mice than elephants. Yet, 3I/Atlas is only the third interstellar object we've detected, and it's by far the most massive. It's like looking out your window for the first time and seeing an elephant before you've seen a single mouse. It's unexpected, but the strangeness doesn't stop there. As 3I/Atlas traveled through our solar system, astronomers noticed something else unusual. The comet displayed what's called non-gravitational acceleration. This means it was speeding up in ways that gravity alone couldn't explain, as if something was pushing it. For comets, this is actually not uncommon. When ice sublimates on one side of the nucleus, it acts like a tiny rocket engine, gently pushing the comet. This outgassing can change a comet's path slightly. But the amount of acceleration 3I/Atlas showed was peculiar. It peaked about 1 month before perihelion, at a very specific value. If this acceleration is purely from outgassing, it tells us specific things about the nucleus, about how much ice is vaporizing and in what direction. The numbers work out, but they're on the edge of what seems natural. They're possible, but unusual. Let me tell you about something that made even skeptical astronomers pause. Scientists calculated where 3I/Atlas would pass in relation to Jupiter, the giant of our solar system. Jupiter has something called a Hill radius. It's the region of space where Jupiter's gravity dominates over the Sun's. Think of it as Jupiter's sphere of influence. This radius extends about 53.5 million kilometers from the planet. Now, here's the remarkable thing. 3I/Atlas will pass Jupiter at a distance of 53.445 million kilometers. The difference? just 60,000 kilometers. That's a margin of error of about 0.1%. This incredibly precise approach will happen on March 16, 2026. Scientists calculated the probability of this happening by chance and came up with about 0.00004, 0.04%. That's really unlikely. Now, unlikely things do happen. Someone wins the lottery. Lightning strikes the same place twice. But it makes you wonder, if you were designing a mission to study our solar system, wouldn't Jupiter be an interesting place to visit? It's massive, it has dozens of moons, and its Lagrange points, those gravitationally stable spots around the planet, would be perfect for placing a long-term observation platform. But let's step back. There's another oddity about 3I/Atlas's orbit. It's retrograde, meaning it orbits in the opposite direction to our planets. Many comets do this, so that's not unusual in itself. But here's the thing. This retrograde orbit aligns with the ecliptic plane to within just 5 degrees. The ecliptic plane is that flat disk where all our planets orbit, like a cosmic record spinning around the Sun. The probability of a random interstellar object aligning this closely? About 0.2%. Another rarity. Why does this matter? Well, if you wanted to visit multiple planets efficiently, you'd want to align with the ecliptic plane. All the planets are there, arranged like beads on a string. You could visit them in sequence, using gravity assists, conserving fuel. It's exactly how we design our space missions. Mars, Venus, and Jupiter, all accessible from this one orbital path. And speaking of timing, there's something else. When 3I/Atlas made its closest approach to the Sun, it was unobservable from Earth. The geometry was all wrong. The comet was behind the Sun from our perspective, hidden at just the right moment. Was this coincidence? Almost certainly. But it's the kind of coincidence that accumulates, that makes you think. The direction 3I/Atlas came from has another strange connection. It arrived from a region within 9 degrees of the famous WOW signal. Now, if you're not familiar with the WOW signal, let me tell you about it. On August 15, 1977, a radio telescope in Ohio detected a powerful signal from space that lasted 72 seconds. It was so unusual, so unexpected, that astronomer Jerry Eman wrote "Wow" on the printout. The signal came from the direction of the constellation Sagittarius, and to this day, we don't know what caused it. Probably something natural, but we don't know. Is the alignment between 3I/Atlas and the WOW signal meaningful? Probably not. 9 degrees is actually quite far apart in astronomical terms. That's 18 times the width of the full moon. But it's another piece of the puzzle, another coincidence to add to the growing pile. Let's talk about what 3I/Atlas looks like up close. Early observations showed it growing brighter as it approached the Sun, which is normal for comets. But it brightened faster than expected, unusually fast. The comet also appeared bluer than the Sun in some wavelengths, which might tell us something about its composition or what's evaporating from it. When scientists analyzed the light from 3I/Atlas spectroscopically, breaking it down into its component colors like a prism, they could identify what chemicals were in the coma. They detected water ice, which is expected. But here's the surprising part. The gas plume contains only about 4% water by mass. Most comets in our solar system are dominated by water ice. They're basically dirty snowballs, with water making up the majority of their ice content. But 3I/Atlas? Only 4% water. What makes up the rest is still being determined, but this low water content is unusual. They also detected carbon dioxide, which is more typical. Many comets release CO2 as they warm up. In August 2025, astronomers found cyanide in the coma, specifically hydrogen cyanide. It sounds sinister, doesn't it? But cyanide is actually common in comets. It's a natural part of the chemical mix, formed in the cold reaches of space. They also detected nickel, the metal, evaporating from the nucleus as it heats up. All of these chemicals tell us about the composition of this traveler, about the environment where it formed billions of years ago. The images from Hubble and other telescopes revealed something else: jets. Streams of gas and dust erupting from the nucleus, shooting out into space. Jets are common in comets. As the Sun heats different parts of the rotating nucleus, active areas release material in focus streams. But the jets of 3I/Atlas, they're different. Some of these jets point toward the Sun. This is highly unusual. Solar radiation normally pushes material away from the Sun, creating the classic comet tail that always points away from our star. But 3I/Atlas has what's called an anti-tail, a stream of material pointing sunward, defying the simple explanation. This anti-tail has been observed by multiple instruments. It's not a mistake, not an artifact, it's real. Other jets point in various directions, some away from the Sun, some at odd angles. The pattern doesn't match what we'd expect from solar heating alone. What's really strange is how tightly focused these jets are. They're collimated, to use the technical term. They stay narrow and distinct over enormous distances. Over 1 million kilometers, these jets maintain their shape, their directionality. This is unexpected. Here's why. 3I/Atlas rotates. Observations in July and August suggested a rotation period of about 16 hours. The comet spins as it travels, turning slowly through space. With this rotation, scientists expected the jets to be smeared across the sky, blurred like a rotating garden sprinkler. But they're not. They remain distinct, tightly focused, as if something is keeping them pointed in specific directions, despite the rotation. Images taken in November 2025 showed this clearly. The jets maintain their structure, their precision. For normal cometary jets, active spots on a rotating nucleus, we'd see a diffuse, smeared pattern. But we see order. We see structure. This is anomaly number 12 in a growing list. The comet also showed unusual polarization in the light it reflected. Polarization tells us about the surface characteristics and the particles in the coma, and 3I/Atlas showed extreme negative polarization. More extreme than any known comet. This might relate to the anti-tail, or to the composition of the dust and gas, or to something else entirely. It's another puzzle piece that doesn't quite fit. As 3I/Atlas approached the Sun, scientists watched carefully for signs of breakup. Comets sometimes fracture when heated by solar radiation. The stress causes them to split into pieces. But 3I/Atlas remained intact, holding together despite the thermal stress. The coma remained roughly spherical, extending about 40,000 kilometers in all directions from the nucleus, a smooth, glowing shell. But from this smooth shell emerged that narrow anti-tail, pointing sunward. The contrast is striking. Symmetry and order, from what should be chaotic outgassing. Scientists calculated how much material 3I/Atlas is losing as it travels. The dust loss rate, combined with the size estimate, suggests the nucleus is actively shedding itself, bit by bit. Some estimates indicate it might be losing around 2 kilograms of hydrogen cyanide per second when most active. That's the weight of a small bag of flour, streaming into space every single second. Multiply that by hours, days, weeks, and you get a sense of the transformation happening as this comet warms. But here's a thought that keeps astronomers up at night. If the nucleus is as massive as estimated, around 33 billion tons, but as small as predicted, less than a kilometer across, it would have to be very dense. Much denser than typical cometary material. Most comets are fairly porous, fluffy even, like freeze-dried ice cream or a hard sponge. But if 3I/Atlas is so massive packed into such a small volume, it might be more solid, compact, structured in a way we don't usually see in comets. The color of 3I/Atlas changed as it approached the Sun, becoming slightly redder. This might indicate changes in what's evaporating, or how much dust is mixing with the gas. Its brightness varied over time too, fluctuating in a pattern consistent with rotation. As different parts of the nucleus face the Sun, different amounts of light reflect toward us. But these brightness variations decreased from July to August, from 0.3 magnitude down to 0.2. This suggests the nucleus became more obscured by its own coma, hidden beneath that growing cloud of gas and dust. Multiple spacecraft and observatories contributed observations. The European Space Agency's JUICE spacecraft, currently on its way to Jupiter, took images. There was hope that NASA's Mars Reconnaissance Orbiter might capture views with its incredibly high-resolution high-rise camera, though the observation window was tight. Every viewpoint matters when studying something this rare. Unfortunately, launching a new spacecraft to intercept 3I/Atlas was never realistic. Scientists calculated the speeds required and found them far beyond our current technology. We could only watch as it passed by. And here's where we come to the elephant in the room. The question that some scientists, most notably Harvard astrophysicist Avi Loeb, have raised publicly. Could 3I/Atlas be something other than a natural comet? Could it be artificial? Now, before you think this is just wild speculation, let me explain. Dr. Loeb is a respected astrophysicist, a former chair of Harvard's astronomy department. He's not a fringe figure. He's also become known for his willingness to consider unconventional possibilities, which has made him both celebrated and controversial in the astronomy community. His argument goes something like this. Humanity has sent technological objects into interstellar space. Voyager 1 and 2, Pioneer 10 and 11. They're out there now, traveling between the stars. If we can send probes outward, couldn't other civilizations send probes inward? Isn't it at least possible? He points to the accumulation of anomalies surrounding 3I/Atlas. Taken individually, each one can be explained. The unusual mass, well, maybe we just got lucky and a big one showed up first. The precise Jupiter encounter, unlikely, but not impossible. The jets maintaining directionality despite rotation. Perhaps there's a natural mechanism we don't understand yet. The alignment with the ecliptic plane, the retrograde orbit, the low water content, the antitail, the extreme polarization, each one, individually, could be explained away. But taken together, the combined probability of all these things happening at once becomes vanishingly small. It's like rolling dice and getting sixes 15 times in a row. Possible? Technically, yes. Likely? No. Loeb uses an interesting analogy. Imagine an AI trained exclusively on images of cats. It learns everything about cats, their features, their movements, their behaviors. Then you show it a dog. The AI might try to classify the dog as a weird cat, because that's all it knows. It's similar, but fundamentally different. His point is that astronomers are trained on comets from our solar system. We know what those look like, how they behave. But an interstellar object, perhaps one that's artificial, might look almost like a comet, but not quite. And we might miss it because we're expecting cats. The hypothesis he's proposed is that 3I/Atlas could be what he calls a mothership. An interstellar vessel designed to deploy smaller probes or satellites, specifically at Jupiter. Think about it from an engineering perspective. If you wanted to study our solar system, but you're limited by the speed of light for communication, you'd want local observers. You'd want satellites in stable orbits around key planets. And Jupiter, with its massive size, numerous moons, and gravitationally stable Lagrange points, would be an ideal anchor point. The precise approach to Jupiter's Hill radius on March 16, 2026, in this hypothesis, wouldn't be coincidence. It would be intentional targeting. A carefully plotted trajectory to arrive at exactly the right distance to deploy something into orbit. And here's what makes this hypothesis scientific rather than mere speculation. It's testable. After 3I/Atlas passes Jupiter, scientists can check if any new objects appear in orbit around the giant planet. Objects that weren't there before. Objects we didn't put there ourselves. We can look. We can verify. That's how science works. Now, let me be very clear. Most astronomers think this artificial hypothesis is highly unlikely. The simpler explanation, the one that requires fewer assumptions, is that 3I/Atlas is just an unusual comet. Weird, yes. Anomalous, certainly. But natural. And that's probably correct. Occam's razor suggests we should prefer the simpler explanation unless evidence demands otherwise. The counterarguments are strong. 3I/Atlas behaves mostly like a comet. It has ice-it-out gases. It has a coma and tail. If it were artificial, wouldn't it be stranger? Wouldn't we see clearer signs of technology? These are fair points. But here's a counter to that counter. An interstellar journey takes an incredibly long time. Even traveling at a significant fraction of light speed, which is far beyond our capabilities, the journey between stars takes thousands or millions of years. During that time, any spacecraft would accumulate material from the interstellar medium. Dust, gas, ice particles. They would coat the surface, building up over eons. By the time it arrived, it would be covered in ice. When such an object approaches a star and warms up, that accumulated ice would sublimate. It would create a coma, mimicking natural outgassing. The very thing that protects it during the long journey would also disguise it as a comet. You'd need very careful observations to tell the difference. The low water content, only 4%, might even support this. If the ice is just surface accumulation from interstellar space, rather than part of the original nucleus, it might have a different composition than ice from within a solar system. Interstellar ice forms differently, in different conditions. The jets maintaining their directionality could be explained by vents on the nucleus, carefully positioned active areas. But they could also be maneuvering thrusters, small engines making course corrections. We see what we expect to see, until we look more carefully and realize it might be something else. The truth is, we don't know. And that's okay. That's the beauty of science. We observe, we measure, we hypothesize, we test. Over time, with more data, understanding emerges. We don't have to jump to conclusions. We can sit with uncertainty and keep investigating. What we do know is that 3I/Atlas will continue to be studied intensely. On December 19th, 2025, just a few days from now as I record this, it will make its closest approach to Earth. Still far away, but closer than it will ever be again. Telescopes around the world will be watching, gathering data, taking images. Every observation adds to our understanding. After that close approach, 3I/Atlas will continue outward, past Mars, past Jupiter in March 2026, past Saturn, Neptune, beyond Pluto, past the Kuiper Belt, until finally it exits our solar system entirely. It will return to interstellar space, continuing its eternal voyage through the galaxy. Where will it go next? That's impossible to say. It might wander for millions or billions of years before encountering another star system. An endless journey through the cosmic ocean. The discovery of 3I/Atlas reminds us how much we don't know about the space between stars. We think of it as empty, as a void, but it's not. Objects are out there. Asteroids, comets, possibly even debris from ancient civilizations. We're only now developing the technology to see them as they pass through. And speaking of technology, we're getting much better at this. The Vera C. Rubin Observatory, which began operations in 2025, is revolutionizing asteroid detection. In just 10 hours of observations, it found over 2,100 new asteroids. Before this, astronomers found about 20,000 new asteroids per year total. Now we're finding thousands in hours. Our eyes are opening to what's been there all along, invisible to our older, less capable instruments. This means we'll likely detect more interstellar visitors. 3I/Atlas might not be as rare as we think. Perhaps there's a steady stream of objects passing through our solar system, and we were simply blind before. Now we can see. Now we can study them. The next few years should bring more discoveries, more mysteries, more opportunities to understand the nature of interstellar space. There's something profound about all this, something that goes beyond the technical details and scientific debates. 3I/Atlas represents possibility. It's a reminder that we live in a universe far stranger and more wonderful than we often remember in our daily lives. While we go to work, pay our bills, worry about mundane things, objects from other star systems are sailing through our neighborhood, carrying stories written in ice and rock and, perhaps, metal. Whether 3I/Atlas is a natural comet with unusual properties, or something that challenges our assumptions about what's possible, it's already served an important purpose. It's made us look up. It's made us question. It's made us wonder. And in a world that often feels small and mapped and known, that sense of wonder is precious. The name Atlas is fitting in more ways than one. In Greek mythology, Atlas was the titan condemned to hold up the sky, bearing an enormous weight for eternity. Our 3I/Atlas carries a different kind of weight. The weight of questions, of mysteries, of possibilities. It holds up a mirror to our understanding and asks, "Are you sure? Do you really know? Have you considered this?" On clear nights, when you look up at the stars, remember that the space between them is not empty. Objects are traveling through that darkness. Ancient voyagers crossing distances we can barely comprehend. Most will pass unseen, their stories untold. But this one we noticed. This one we're watching. This one might, just might, be watching us back. In December 2025, as 3IATLAS makes its closest approach, astronomers will be recording every detail they can. In March 2026, as it reaches Jupiter, they'll be watching even more carefully. Watching to see if anything changes, if anything separates, if any new objects appear where none existed before. It's a rare opportunity to test a hypothesis that seems impossible, but isn't quite. And regardless of what we find, regardless of whether 3I/Atlas is comet or craft, natural or designed, we've already learned something invaluable. We've learned that our solar system is not isolated, that visitors arrive from the cosmic ocean, that between the stars, in the darkness we once thought empty, there is traffic. There are travelers. There are mysteries waiting to be discovered. We're living in an extraordinary time. For all of human history until 2017, we never detected a single interstellar object passing through our solar system. Now we've found 3 in 8 years. As our technology improves, as our surveys become more comprehensive, we'll find more. Perhaps dozens, perhaps hundreds in the coming decades. Each one will be a messenger from distant realms, carrying information about other solar systems, other conditions, other possibilities. 3I/Atlas, with all its anomalies and mysteries, has shown us that these visitors can surprise us, that they don't always behave as we expect, that the universe is full of phenomena we don't yet understand, and perhaps, just perhaps, some we never imagined possible. So as you drift off tonight, as you close your eyes and your breathing slows, picture this. Somewhere above us, moving through the darkness at impossible speed, a visitor from the stars continues its journey. It came from somewhere we cannot see, traveling for perhaps billions of years. It will pass Jupiter in a few months, threading through space with remarkable precision. And then it will leave, sailing back into the darkness, continuing a voyage that may never end. Is it ice and rock shaped by chance and physics? Almost certainly. Is it something more, something that challenges everything we thought we knew? Probably not, but we're watching. We're learning. We're open to wherever the evidence leads. And that's the story of 3I/Atlas. A mystery written in starlight, a question mark in the sky, a reminder that the universe is larger and stranger than our daily lives let us remember. Whatever it is, wherever it came from, whatever its destination, it passed through our small corner of space, and for a brief moment, we got to see it. We got to wonder. We got to dream. Sweet dreams and clear skies. The universe is full of wonders, and some of them are passing by right now.